inteso non come di ambiti disciplinari, ma come integrazione sostanziale. Educare oggi significa infatti formare soggetti capaci di abitare la complessità, senza ridurla, di attraversare linguaggi differenti e di riconoscere nelle intersezioni tra i saperi non una criticità, ma una risorsa. So che oggi andrete in visita alla mostra di arte e scienza, Opus Mundi, e la mostra ha lo stesso paradigma, un percorso in cui la produzione artistica dialoga con il metodo scientifico e in cui la tecnologia non si limita a mediare, ma contribuisce a generare nuove forme di conoscenza e di espressione. Sono certa che il vostro confronto di oggi non solo approfondirà gli ambiti specialistici, ma contribuirà anche a rafforzare questa visione unitaria del sapere di cui oggi più che mai sentiamo la necessità. Buon lavoro a tutte e tutti e buona giornata.
Okay, we're getting ready for the round table, but I would like to verify if Professor Ubertini is connected.
Sì, buongiorno. Buongiorno, Mi sentite?
Sì?
Sì, buongiorno a tutti e a tutte. Diciamo, mi dispiace molto non essere lì con voi, però mi faceva piacere comunque portarvi un saluto e fare qualche ringraziamento. Innanzitutto il ringraziamento agli organizzatori di questo convegno, di queste 2 giornate, un ringraziamento alla Fondazione Golinelli e al Museo della Musica, ai 2 progetti ERC nell'ambito dei quali è stato promosso questo convegno, in particolare a Michele Ducceschchi e Massimiliano Guido. Un ringraziamento ad Alfa Sigma che è il main sponsor dell'evento di oggi e di questi 2 giorni di questo convegno e al Ministero della Cultura. E, ne approfitto per fare una considerazione che riprende in qualche modo l'intervento precedente. Noi stiamo vivendo quella che secondo me è un vero e proprio cambiamento d'epoca, spinto dal progresso tecnologico e dalle nuove tecnologie digitali. In questa trasformazione, in questo cambiamento che stiamo vivendo, si sta modificando la nostra società, non solo il modo di fare impresa, ma anche il modo di relazionarci, di rapportarci allo spazio, di rapportarci alle cose che ci circondano, la nostra relazione con il tempo. E queste tecnologie hanno la capacità di amplificare le nostre capacità di esseri umani, sia individualmente che collettivamente. E questa fase storica richiede una visione integrata, diciamo, la capacità di dialogare, richiede confronto tra professioni diverse, richiede una nuova prospettiva e io sono un ingegnere e quando mi chiedono come penso, sono anche professore universitario, quindi quando mi chiedono come saranno gli ingegneri del futuro e come dobbiamo prepararli, io ritengo che dopo decenni in cui siamo andati verso l'iperspecializzazione, è arrivato il momento di fare qualche passo indietro e di tornare ad una visione dell'ingegnere più rinascimentale. Questo, visto dalla mia prospettiva, in realtà, per quello che dicevo prima, ha una portata più generale. Bene, in questo quadro, leggendo la paginetta di accompagnamento che descrive questi 2 giorni, le parole che ho citato compaiono tutte, compare un passaggio sulla trasformazione legata alle tecnologie digitali, viene richiamato l'approccio interdisciplinare tipico dei progetti IRC, della necessità di mettere in dialogo musicologia, ingegneria, acustica, informatica, architettura, restauro, gestione, cito dal documento, la necessità di avere una prospettiva interdisciplinare, legando il patrimonio musicale alla ricerca, all'innovazione tecnologica. Viene richiamata una visione integrata del patrimonio sonoro come bene culturale, scientifico e sociale, e la necessità di un confronto tra saperi diversi per affrontare le nuove sfide o per sfruttare le opportunità della contemporaneità, quindi studiosi, ricercatori, conservatori, restauratori. Beh, io penso che sia davvero molto importante, e quindi anche semplicemente questo è lo spirito del saggiatore musicale, quello che credo abbia spinto i colleghi musicologi a scegliere me, un ingegnere, come presidente del saggiatore musicale. È certamente nello spirito del luogo che ci ospita, che vi ospita oggi, perché questa era la visione di Marino Golinelli, che quel luogo l'ha creato e gli ha dato un'anima. E quindi il mio auspicio è che possano essere 2 giorni ricchi e che questo possa essere il primo di vari momenti che poi potranno essere organizzati in spazi come questo negli anni a venire. Grazie, grazie davvero e buona 2 giorni.
Per queste parole e grazie anche alla Fondazione Golinelli e alla sua direttrice scientifica che ci ospitano. È un piacere per noi, per me, Massimiliano Guido e Michele Ducceschi, essere qui. È un momento di confronto, è un momento di integrazione fra progetti diversi. It is a pleasure for me to be here, and thanks for hosting us. This is an international conference where I know that we have many people registered online, and so welcome also to you. We have question and answers, and we have people as co-hosts that will take care of collecting your answers and your questions and your remarks during the day. Sorry for the little delay. It was a nightmare to get here, but we finally arrived. So should we start and call to the stage our principal investigators or projects that are in Horizon and ERC, EVA Pietroni, and I hand it to Michele, who is sharing this session with me.
Thank you, Massimiliano. It is a pleasure to be here for myself and the people from NEMUS, Sebastian, Riccardo. Eva, please come to the stage with us. There is a spot for you right here. And Eleftherios, are you with us, connected?
Good morning, everyone. Yes, I'm here.
Good morning, Eleftherios. It is a pleasure to be here. So I think we'll do the roundtable in English. Yeah, if that's okay, because we have many international guests.
Yeah.
So I'll do a round of introductions and of the projects, and then I'll let everybody present their own projects. But this is a roundtable with 4 Horizon-funded projects, so it's really one of a kind, I would say, because it is very rare to have this many Horizon projects all together in the same room presenting, and all sharing a lot of the themes and issues that will be thoroughly debated in the next 2 days. So Eva Pietroni is a research director at CNR, coordinates a consortium including CNRS MAP, the Museum of the Violin in Cremona, and she has partners in Hungary and all over Europe. She's one of the leaders of the PlaceMus XR. I don't know if I pronounced that correctly. I'm not sure if I should use the Latin pronunciation or the English one.
You can use both.
Okay. Okay.
If you speak about music, PlaceMus. If you speak about PlaceMus.
All right. Okay, I see. That's very smart. That's very smart. So very briefly, obviously, Eva will describe her project in detail, but this is precisely a project about places and instruments. Places where music takes place or used to take place. So it's a project that maps places of music across European cities and regions. Concert halls, churches, workshops, and weaves them into thematic itineraries navigable through augmented reality and virtual reality. Is that right?
Yes.
Cool. That's a very nice project. And then we have Eleftherios connected from Thessaloniki. Is that right?
Right.
Okay. That's right. Who is also one of the investigators of a big Horizon project, MusicSphere, which operates within the European Collaborative Cloud for Cultural Heritage, ECCCH. I think Eva is also part of that same network. So that's a shared digital infrastructure developed within the ECOS framework. And the project addresses what it calls dynamic heritage objects, artifacts whose identity is inseparable from motion and sound. The primary focus is traditional pipe organs and the ancient Greek hydraulis, a water organ. And these are instruments defined not by static form, but by airflow, mechanical action, and acoustic radiation into architectural space. So welcome, Eleftherios will let you speak very shortly. I will also present Massimiliano, who is co-hosting the Congress along with myself. Massimiliano is one of the principal investigators of the Remake Synergy project, which is among the most prestigious ERC projects. It's a synergy, so there are multiple PIs involved. Massimiliano, who represents the University of Pavia within the musicology department in Cremona. And then Andrea Schiavio is the second PI at the University of York. And Joel Spestra, who is a historical performance and expert and instrument builder from Göteborg, Sweden. This is a massive project that's just started, which targets historical keyboard instruments that survive in museum collections but are too fragile to play. And then myself, I'm in charge of the NEMUS project, which, as opposed to the projects that I presented, is almost finished. So we are right at the end of it. My project is concerned with virtual modeling and particularly real-time sound synthesis of instruments that are currently unplayable and that belong to museum collections or private collections. So that's myself done with the introduction, and I would think maybe we can let Eva present her project in more detail.
Good morning, everyone. Thanks again for the invitation. I am really very happy to present this project, the PlaceMus XR. It's a digital journey across musical places in Europe. It's a new project because it started on the 1st of October 2025, and it's a part of the ECOS ecosystem. You know, the European Cloud for Cultural Heritage, Collaborative Cloud for Cultural Heritage, is a huge initiative at European level to create a software infrastructure integrating data set tools to enhance accessibility and reuse of European cultural heritage. And around this initiative, many projects have been founded. And among this project also our project that is about the development of innovative tools to enhance interaction with cultural objects. So it's mainly for museums, for the wide public, for the educational sector. So I am Eva Pietroni. Just a short introduction about me. I am a research director at the Institute of Heritage Science. My background is in conservation of cultural heritage and art history, and also in music, because I studied music, and so this is I am very happy to create a project also integrating music, because usually when you deal with the digital cultural heritage in the field of archaeology or art history or architecture, and even when you visit places in cities as a tourist, you usually don't deal with sonic heritage and musical heritage. It's a discipline that is usually quite separated from the other domain, cultural domain. And in our project, we would like to reconnect these. So the idea is to create digital tools to enhance accessibility, knowledge, and appreciation of European cultural heritage. And we want to transform the way we experience music in our cities, museums, and schools. Not only music, but sound in general, sonic heritage. Not creating archival contents, databases, but multisensory and engaging experiences journey through virtual reality, augmented reality, immersive sound, the virtual reconstruction of historical soundscapes, and developing a set of digital tools that can be used by different kind of audiences. Why extended realities? Because the idea is to contextualize musical repertories in the original places where they were composed or performed for the first time, the places of patronage, and in reconnecting the musical heritage with the general historical and cultural context with the physical museum objects, and also considering the fundamental relation between the sound and the space, the architectural forms and the music. Because of course this interconnection is fundamental in the development of musical practices, in the development of instruments, in the evolution of also the art of making instruments, the disposition of people inside a space, and in general the musical events as a whole. When we speak about place of music, we consider different places, places where the music was performed, where it is taught, where it was commissioned, acoustically interesting places, workshops for making, for instrument making, also places which have transformed along the time, or which have been completely destroyed, but we have still a memory. And in this case, we have the virtual reconstruction of a historical soundscape. And so here you can see some example of different topics around the place of music. What the place of music is, who are the actors, which is the concert formula, and so on. Here you can see a short and a simple representation. And around this, we have developed an ecosystem of tools. You can, as a user, select a profile. So you can decide to explore this musical itinerary as an architect, for instance, or as a musician, or as a child, or as a geographer. And according to the profile you select, the itinerary will configure according to your interest and preferences. These tools will be implemented with some case studies. We have selected at least 7 itineraries around Europe that are different in terms of musical genres, chronology, geographic location, and audiences. For instance, we have the polyphonic Georgian polyphony, sorry, the Italian madrigal, the pop music, the folk Hungarian music, and so on. But of course, the tool are conceived as open. It means that you can create new content and new itinerary using this infrastructure to generate further contents, and you can also reuse the existing contents. Here there is just a short overview of the itinerary. We have also an itinerary about organs in Krakow. And special attention is also addressed to accessibility issues with some tools that are specific for enhancing accessibility to the musical heritage for deaf and blind people. The consortium is really heterogeneous. We have experts from musicology and humanities, social science, acoustic and engineering, ICT sector, and user studies. And the partners, we are 11 partners from 6 European countries. The CNR, our institute, is leading the consortium together with CNRS, the University of Tours, the Center for Renaissance Studies, Musical Studies, and creative industries, and so on. And we hope to have an impact on different target groups, from museum professional to creative industries, educational sectors, students and professors, and of course the also local communities and tourists and wide public in general. I think I have finished my time, so thank you.
Thanks a lot, Eva. That's really, really amazing. Very, very cool project. I'm wondering whether anybody in the audience has questions. Because I was curious about the idea that users can create their own content and add it. How does that work?
The tools that we will develop will be implemented with some case studies, but the ambition is to transform these prototypes to template. This means that when you will access a digital tool, you will find an interface allowing you an infrastructure, let's say, allowing you to select your contents that, of course, should be compatible, compliant in interoperable format, FAIR principles, and you can populate through following this template the general infrastructure of the itinerary with your content. And you can also select the kind of itinerary, because you can have an itinerary that is based on a musical genre, for example, or it's based on a biography, a musician, or it's a territorial itinerary, for instance, place of music in Ferrara. You have different places of music in different ages and typologies, or site-specific, a museum. You can create an itinerary inside the museum or a castle. So accordingly to the concept that is on the base of the itinerary, you can configure, and you can create also different user profiles, in order that you as a user can select the topics of your interest. If you are interested in acoustic, for example, the relation between the music and the space, you will enter, for instance, as an architect, and the itinerary will propose you what is most interesting for you.
Maybe if I can jump in, since we have seen the little cloud graphics and we will see it again on Eleftherios' presentation, if you could say something about the ECOS infrastructure, because it is extremely important to know that these are projects that are inserted in a bigger vision that is to create a digital infrastructure for cultural heritage.
Yeah, we want to.
Yeah, if you can just.
Yes, the ECOS project is composed by a consortium of 53 European partners, including the main research institution of Europe. And the idea is to create a workspace especially addressed to scholars, researchers, where they will find a data set enriched with metadata, of course, in interoperable formats that can be reused, of course, under different types of licenses, but the general philosophy is open data. Open science, and also not only data set, but also tools. And these knowledge share the same ontology, that is the heritage digital twin ontology, and the same knowledge base. So we, as projects involved in this ecosystem, will be engaged in a creative part, of course, but also in a very rigorous way to work and to prepare data and to integrate tools to map our data on this ontology. And for this, there is an integration task force that was composed of experts in this domain.
Wonderful. Thanks very much, Eva. I will probably ask Eleftherios if you want to introduce your project and share your screen with us.
Yes, sure. Can you hear me?
Since we are talking about ECCHS, then I think it's appropriate.
We need to. Can you speak, please, Eleftherios?
Yes, can you hear me? Can you hear me?
We can't hear you and we cannot see your screen either.
I've sent, it is pending to give me access.
Yeah, you need to ask for permission.
Okay, okay, I think I can fix now. Can you see my screen?
Yes,
oh, yes,
we can.
Great. Thank you for the invitation. We will present the MusicSphere project, a multimodal approach for digitizing, analyzing, and simulating traditional musical organs through 3D technologies, acoustic analysis, and interactive experiences. I am Eleftherios Anastasovittis, member of the coordinator team of the project. I'm alongside with Dr. Spiros Nikolopoulos, Dr. Ioannis Kobatsiaris, and Ms. Georgia Georgiou. Center for Research and Technology, Hellas, through the Information Technologies Institute, and more specifically through the Brain Health Virtual Research Group. We are coordinating this project, as well as another sister project, Excalibur, with a totally different perspective. The MusicSphere project is funded by the European Union, and it is among the ecosystem of the ECCCH infrastructure. The MusicSphere project has started in the same time period with the PlaceMus XR in October. The duration of the project is 42 months, so we are in the month 6 of the project. MusicSphere is a European project that uses advanced digital technologies to preserve, study, and share traditional musical organs, create digital replicas, simulate sound and acoustic, and also enable interactive experiences enriched with historical knowledge. The consortium, 12 partners are under the MusicSphere project. CERT is leading this, and it is interdisciplinary research project. So we've got the luthieros and two church organs, Schumacher and Kleist. We've got the Fraunhofer with two departments, IBP and IDMT. We've got the University of Malacca and also the International Hellenic University. Regarding communication, dissemination, and training activities, there will be the EuroXR, Heritage Management Organization, and VLabs, and also we have the Technical University of Ilmenau. The MusicSphere is part of this ECCCH ecosystem. The Cultural Heritage Cloud is a shared platform designed to provide heritage professionals and researchers with access to data, scientific resources, training, and advanced digital toolkits tailored to suit their needs. ECCH brings together fragmented communities of the cultural heritage field into a new community around the digital commons. About the MusicSphere project, the project aims to develop tools that combine advanced technologies for preserving, studying, and providing access to the cultural heritage aspect of traditional musical organs. The project will focus on traditional wind instruments such as pipe organs and their ancestor, the Greek ancestor, the hydraulis, by employing digital technologies. Precise digital replicas of these instruments will be created, capturing intricate physical and mechanical details and aiding in the preservation and restoration efforts. The study will involve analyzing unique sound characteristic of the organs and utilizing acoustic simulations in order to accurately recreate their tonal qualities and the interaction of sound with surrounding architecture and environmental conditions. We've got also virtual and interactive tools that will be developed to simulate and handling of these instruments, providing providing platforms where users can experience them in digital and immersive reality, augmented reality environments. By integrating 3D visual data, acoustic properties, and interactive models into a cohesive system, the research will try to offer a holistic understanding of the instrument's artistic and functional significance. The results will contribute to the long-term preservation of these cultural artifacts by creating digital archives and enhancing public and scholarly access through interactive technologies and educational applications. Another key objective is the projection of the results to the past in an effort to approximate the acoustic characteristics of non-functional musical instruments. We've got these two representative use cases. The first one about the ancient hydraulics, focus on fragmented remains and limited archaeological data, with main objective digitally reconstruct the hydraulics and preserve its sound for interactive exploration. As I mentioned before, hydraulics is the ancestor of the church organ, the second use case, where complex instruments strongly shaped by church acoustic, and with the main objective for use case 2 to preserve historic organs and enable interactive exploration. So we have to preserve sound and motion, protect the originals, and rebuild lost sounds with these 5 expected results: immersive XR experiences for museum and classrooms, precise digital replicas of historical instruments, accessible archives for researchers and the public through the ECCCH ecosystem and infrastructure, and above all, a deeper connection between cultural heritage and technology, and also new methods for preventive conservation using AI and sensors. We've got a set of toolkits, these 9 toolkits with their assigned technological readiness level. Toolkit number 1 is about simulation models of wind pipes and traditional musical instruments, airflow calculation, parameterization, and data generation. This toolkit deals with finite element method, computational fluid dynamics, simulation models of wind pipes and traditional music instruments, and also auralization and changes in sound quality. Regarding the second toolkit, that focuses on physical, virtual restoration of cultural heritage musical instruments, this toolkit deals with the creation of original sound, reconstruction of original appearance, digitization of artifacts, simulation, and craftsmanship. Don't forget that we've got also the use case of the ancient hydraulics, and also deals with advanced imaging techniques, prototyping through 3D printing, acoustic testing, and iterative refinement. We've got also a very interesting toolkit number 3 about acoustic profile digitization of architectural spaces. This toolkit deals with capturing and modeling of the acoustic profiles of architectural spaces, directional impulse responses, ambisonic recordings, comprehensive understanding of the sound propagation, reflections, and reverberation patterns unique to the environment. Regarding the toolkit number 4, we've got long-term acoustic projection with that. This toolkit deals with AI and computational models for sound quality over time, simulation of environmental and usage effects on acoustic properties, and also prediction of future acoustic transformation among all. Toolkit number 5, it is about predictive modeling for material deterioration and sound degradation. This toolkit deals with predictive maintenance for musical instruments based on simulated acoustic data and environmental factors, and also reverse predictions of an instrument's original sound. Regarding toolkit number 6, we propose interactive XR experiences in extended reality with specialized acoustics. Regarding the toolkit number 7, it is our, let's say, main effort in integrating all these different toolkits in the same place before we integrate them in the ECCCH infrastructure. Regarding toolkit 8, it is about real-time polyphonic music transcription with tunic adaptation. And toolkit number 9, it's about real-time AI-based synthesis of historic music organs for virtual instrument performance. So here we've got AI-based sound synthesis models that convert note-level performance parameters extracted with toolkit 8, the previous one, into realistic music organ sounds. As an example, virtual keyboard interfaces generate control signals to guide the audio synthesis. So we've got multiple target groups who will benefit from our toolkits, such as heritage institutions, musicians and organists, general public, creative industries, for sure the ECCCH ecosystem, researchers, educators, and stuff like that. And another very interesting point here that I will ask all of you to, let's say, participate in this. It is the opportunity to contribute with the MusicSphere through financial support to third parties through open calls. We will offer up to 8,140 euros in 14 projects. Each project will receive up to 60,000 euros, and with a duration of 9 months, you will have the opportunity to test, evaluate, and further improve our toolkits. The proposed timeline, it is as following. Application period is from April 2027 until June 2027. The selection period of the succeeded project will be between July and September of 2027. And we are expecting to start the implementation of this FSTP project around January 2028. As I mentioned in the beginning, our project is funded by the European Union, and it is part of the ECOS project. And feel free to follow us through the official website, and also through our social, and stay connected with these opportunities to collaborate in this very interesting, let's say, initiative. That's from me.
That's wonderful. It's a great project. It's big. How many partners are involved again?
We've got 12 partners, and CERT is leading on this, and also Fraunhofer from Germany participates with 2 different departments. So yes, it is something huge.
That's great. So what about yourself? Which part of the project will you be mostly involved with?
Yeah, thank you for this point, Michele. We here at CERT, ITI, our research group, we focus on immersive technologies, VR and XR solutions for cultural heritage, mainly for cultural heritage. So we will focus on toolkit number 6, but as coordinator, we are involved in all this horizontally in all these solutions.
Okay, that's great. Are there any questions from the audience? No, then I will probably move on to Massimiliano because I would like to save maybe a couple of minutes at the end of the presentations for a quick chat among the four of us.
Thank you, Michele, and thank you all for this exciting moment of sharing. And it's not a case that there is a cluster of projects financed by EU that deals with musical instruments in different ways. I think it is a strategy. It's really trying to put money into different think tanks and then to shake it up a little and then to try to get results that are viable for different kind of communities. So there is, as you will see, quite a lot of overlapping in the digital part of Remake and MusicSphere, but we also have a different angle that is also due to the structure of the program that we are using, because the two previous one are consortium. Our is an ERC, so it's centered on the PIs. For the synergy, we are free of us. And also Michele had an ERC. So again, starting about a research question generated by a smaller team with different competencies. So Remake is a synergy project. It's the first ever attributed to musicology and musical instruments. So we are pretty proud of it. It's generated by 3 universities. Main host institutions are University of Pavia, myself are there, the University of York with Andrea Schiavio, and the University of Gothenburg with Joel Spessler, that is also here physically with us. Hi, Joel, we will talk with you later. Recently, we had 2 other beneficiaries, the Polytechnic of Milan, its campus of Cremona, because of the connection with the acoustic analysis that we will run, and also the work on digital twin and neural networks that is part of our digital transition, and the CNR, the Istituto per le Scienze del Patrimonio Culturale, with Costanza Migliani and other researchers that will follow. So we have 4 main research questions. The first is we try to make a dialogue between different disciplines, namely organology/musicology, cognitive science, performance practice, artistic research, and computer science. Can a dialogue between artistic research, organology, and cognitive science create a new framework to better explore the complexity of music making? We are not dealing only with historical cultural heritage. We are dealing with a complex network of objects and people and spaces that interact with each other and create this wonderful thing that is music. So Remake has the ambition of not only going with for the objective quantitative data, but it has the ambition to go for the qualitative, artistic, related, aesthetic approach to music and musical instruments. So we need a cluster of different disciplines in order to achieve this kind of result. We want, therefore, to transform our understanding of musical instruments. How can we improve traditional organology that was not able to communicate the dynamic behavior of a system if we want to reduce the musical instruments to something that engineers could appreciate and work with, we might use the system or the interface as a keyword to facilitate the dialogue. Then we have to have a huge discussion about terminology at a certain point of our moaning or sessions. We want also to investigate the role of embodiment in musical experience and instrument building. How do performers, educators, listeners, and builders describe their engagement with musical instruments? Objects alone don't tell a lot. We need people in the present to understand what people in the past did. Before digitizing and transitioning into a new era, we need to understand and we need to recreate the physical experience of these objects and the relational network that they create. Otherwise, we risk to lose details that are in the network and not only in the object. So in so doing, we'll try to reshape our experience of historical instruments also in a more accessible and sustainable way, because all this digital transition should create more accessibility and more occasion to interact with digital forms of fragile objects. How can we use new technology to study and safeguard the historical objects and to create more faithful copies? So in order to do that, we envision this kind of research framework called cognitive and digital organology. I'm not going to comment too much on it. Notice that people are in the center and they relate with the different kind of actions and interactions that connect historical objects that are also musical instruments, and there is a huge debate of what to do with historical instruments in order to preserve their value of sounding objects, but also historic documents. We will see some different case studies about how we could decline this in order not to lose any of their importance, but also to preserve them for a better future. And a dialogue with copies that are built. We need builders to be part of this project. We need their experience. We need their knowledge. We need to understand that the research questions are not only the ones that are generated by scientists, but also the ones that are generated by this kind of expert that are have such a strong embodied connection with what they do. And also, the digital world is used here for creating some new tools that could implement our approach to reality. The Synergy is a 6-year project. We're starting in the September of 25, so we were just in the mindstorm of bringing together different disciplines, finding terminologies that is coherent, and also to bring together different perspectives about the same topic. Because believe me, if you talk with an acoustician and a computer science about a soundboard or how to capture its quality, you need to have a mediation with some exchange of what is important to you and what is important to the other. The attempt is to work on the concept of microhistory that becomes a microecology, because musical instruments are so big and so diffuse, and they are so complex that if you want to capture details that are meaningful to all these different group of people, you generate a huge amount of data, and then you need to handle them and to make them significant for, again, different people. So we decided to focus on the artisanal period where these human amount of interaction was extremely important to determine the sound qualities of the product, and to work with artistic researchers that will inhabit these reconstructions of copies and these historical instruments and create experience. And so we will document the human being inside this little contained experience. We just started the first synergetic action with this framework. One first question that I like will be also approved and discussed during these days is what makes a good sound? What makes sound? So are we sure that we are considering all the details as the ancient builders were doing, or are we missing something? Can we reduce the instruments to a soundboard and to a string and to an activator, or do we need to have an holistic approach? It's a challenge. We need a documentation protocol that can take and support and transfer the complexity of different data sets. We need to deepen the process reconstruction of each single instrument, and then we will set up the microecology. In the second phase of the project, we will explore this microecology using artistic research, which is a powerful tool if it is used well, and if it is in connection and in a controlled environment. Artistic research can be also used in the lab. Yes, I dare to say that we need a human element also in science, and it is essential to keep the experiential part connected to the statistical and objective observation. We need to create digital tools for builders. So we're looking forward to using some of the toolkits that Eleftherios and the other friends will develop, because this will improve the adaptability of different projects and also create even more synergy in this huge amount of money that Europe has given us for a reason, I believe. We will be also able to discuss with conservators and restoration professionals new ways of working with historical objects. We are in a town that is really connected with a long of tradition. We will have a roundtable about it. So it's a challenge in the challenge, and it's extremely important. So we will, in a sort, generate new embodied knowledge. And then, of course, we need to transfer it in a different way. And it's where the collaborative part, the digital infrastructure, how we share and make data significant to others will have a strong part. And it, of course, my take is that we will arrive to a sort of a new artisanship, where there will be maybe a little bit of AI, quite a lot of science and technology, but we need artisans also in the 21st century in order to create the complexity and nuances of historical instruments. So I just finished with the people that are the most important things. As you see, we have called it the remakers, and they are advisory board experts, PhD students, senior researchers, and Remake is made of many, many thinking people and living people and very enthusiastic. So it's a great moment for us, and thank you for your attention.
Thank you, Massimiliano. We're kind of running out of time for this roundtable, so I will be very brief with my presentation because I will present shortly after, but maybe we'll leave time for a couple of questions at the end, okay? NEMUS stands for Numerical Restoration of Historical Musical Instruments, and I will be a little more thorough shortly, so this bit will be pretty brief. But I would like to talk about the logo first, because that's one of the things that, you know, it is very striking. I didn't come up with it. I asked somebody to think about NEMUS, somebody that is completely outside of musical acoustics or organology or musicology, a designer, a graphic designer. So I told her what the project was about, and I asked her to think about, a reasonable logo to define the project. So she came up with this interesting idea of drawing, well, let's say a soundboard that could be the soundboard of a harpsichord or maybe a piano. And then you can see these wires that are sort of leaving the soundboard and entering the black keys underneath. So the wires could represent maybe the strings of the harpsichord, or perhaps something a little bit more metaphorical. And the black keys at the bottom as well could be representative of what you find in an actual keyboard, an instrument keyboard. But for us, they really are it really represents time. And not continuous time, but discrete time, zeros and ones, because what we deal with, particularly within NEMUS, is numerical simulation, digital simulation that doesn't understand continuous time, but it can only work at sampled time steps. So this logo is very representative of what we do, because it really reflects the attempt to reproduce the sound of historical musical instruments through digital technology. As opposed to the other projects, which seem to have many partners within their teams, our team is kind of small because this is a starting grant, so no partnerships. Well, obviously, it's me, and then a couple of postdocs, Craig and Hannah, and then a few PhD students. Not a lot of us, but we did a lot of work. We're kind of towards the end of NEMUS. And again, just like the other projects, we deal with the idea of musical heritage. So ancient and valuable instruments are subject to wear and deterioration, even when strictest conservation measures are in practice. So for us, the central idea is to work with museums and to develop copies, digital copies in this case, or maybe hybrid copies that have a digital component and a mechanical component as well. We will go through a lot of these research teams shortly, so I will be very brief. But I will just probably spotlight this part of the project, which deals with building mechanical controllers for digital instruments. So we worked with Roberto Livi, who is here with us today, who was really instrumental into developing, certain parts of the projects. And he built this keyboard for us, which you can hear, but what you hear is not the sound of the keyboard. It's the sound of a software that is controlled through the keyboard. Sorry, I will try to move back. No, there is no sound here. So generally, I would say that what we're doing is some kind of virtual Lutherie. So it's towards a new framework for conservation. And central to our project is the idea of developing fast and reliable tools for simulating the behavior of musical instruments. And musical instruments are extremely complex. So managing to shrink down the behavior of an instrument to real-time performance is extremely complex. But that's precisely what we've been focusing on, along with the integration of these digital simulation tools with mechanical control devices. So, we delivered the keyboard to San Columbano, which is now a part of the permanent exhibit. So if you want to check it out whilst you're in Bologna, you can. And I will probably end here just because I will talk a lot more about NEMUS shortly. So I will take questions if you have any. Or maybe we have time for a couple of questions in the roundtable. What do you think?
It's up to you and them.
Let's see, how are we doing for time? I would say I don't know. There's lots of things that came up from this roundtable, but I think that one idea that is really central is the idea of well, synergies. Precisely, that's you know, a part of you know, the kind of grant that Massimiliano has, but synergy in general for this kind of project seems really central. So my team is really small, but your teams are a lot bigger. So my question for you is perhaps how how does this synergy work? How complex is it to pull all these people together working on one project? Because I have no direct experience with it, but Eva probably is a lot more used than me working in big teams. Everybody has a different role and so such broad competencies. So I don't know if you could share maybe any insight as to how difficult it could be to realize a project such as yours that requires that so many different people with such broad competencies.
Yes, of course, it's an ambitious perspective because there are different kind of expertise and skills in the consortium, but we are just at the beginning. So at this moment, we are organizing different webinars in the consortium in order to understand better what all the partner can can make for the project, starting from analyzing the already existing tools that we have in our laboratories, because we don't start from zero. Of course, all these tools are already existing and they will be extended, integrated, and improved for the project. And so the first step is to try to understand each other and share perspective in a very informal manner. And for this reason, it's really important to have some persons bridging the different sectors. And in our cases, for instance, I can speak about our unity at CNR. We are mostly from the humanities, archaeology, architecture, art history, but we are working for many years on virtual museums, in digitization, interaction design. So probably we are one of the partners able to bridge these different domains. But this is also the most challenging and interesting part of the project, to work on processes. And I think this is very
Is there like a main leader across all the partners, or is it very horizontal? Like, is there like a boss basically that runs the whole thing, or is it very sort of horizontal and properly partnership wise?
Sorry, no.
All I'm asking is because there are so many partners involved. Is there like a proper sort of head of the project that runs most of of the managerial side of things, or is it more?
Yes, we have the executive board that is composed by the work packages leader, and this is quite heterogeneous in terms of competencies, because you have seen we have universities, we have research laboratories, creative industries, people coming from the user studies domain, and this is also very important. We have curators, for instance, we are collaborating with the Museo Internazionale della Musica qui a Bologna. And so the idea is really to join the different perspective, and for this purpose we are organizing many meetings and brainstorming, sharing perspectives.
Okay, wonderful. Max, I don't know if you wanted to add anything to the roundtable, perhaps sharing your own view of what it is like to work within synergial
It is
competencies.
a challenge, but it is also extremely enriching because you are always questioned with new perspectives. So your beliefs that as an organologist maybe you could have of how to approach a musical instrument are put under scrutiny. And so you have not to defend, but you have to accept and do a lot of listening and a lot of mediation, and you generate new idea. The risk I can envision in such big projects that we promise to do too much because it's part of the application game. And then we come to reality and we discover, oh, Lord, what have I done? And I need to find strategies and looking internally, but also externally to create these networks of research cluster is a key strategy because for instance, we are developing a lot of technology that already exists or could be modified. So the great idea of Europe, I think, is open access and interoperability of data. And this is a great achievement.
And you said something last night at dinner that struck with me, which is that you don't want to reinvent the wheel.
Yeah.
So what is the wheel that you don't want to reinvent?
For instance, the way to keep data organized, or to rely about proprietary data sets or database systems. There are now much extensive research already done and toolkits that are available. I think Eleftherios raised his hand also, so I want to say something.
Yeah, I totally agree with all of you, with you, Max and Eva. It is very complicated to coordinate a project in this size of this size. First of all, during the preparation of the proposal, no one knows anything about different toolkits or approaches from other projects. When the MusicSphere was selected for funding, this first stage, we are trying internally under the coordination of SERF to define exactly what each toolkit will offer to the community. On the other hand, we've got a sister project with a similar perspective and approaches. So there is a possibility to have some toolkits or solutions that are overlapping. So there is a major need for collaboration, and for example, this roundtable is one action of to this direction to understand better what our solutions offer and how we can collaborate and interact just to save time, resources, and stuff like that. The good thing is that ECCH is under open source, open access, open science, and all solutions will be in this direction. And for sure, all different toolkits and solutions needs to be in alignment with the ECCH infrastructure. So there is also a need for intensive collaboration in this ecosystem. ECCH ecosystem will be consist of around 20 to 25 projects, but also include here some projects through open calls or financial support to third parties. So the number will be very huge. Yeah, this is from our side, and just to add to what Eva said, we are organizing a webinar next week between the PlaceMus XR and the MusicSphere, where all the partners will interact with the description of the solutions, and we try to understand better what are the opportunities here for collaboration, for early exchange of knowledge and methodologies, and stuff like that. And also thank you, Max, for inviting us in a previous conference in Padua, where we all started collaborating. I mean, the remake and MusicSphere project.
Thank you. Thank you very much. And thanks, Max, for organizing this. And I think we should really call this off because we're running a little late. But I would like to thank the speakers again for their wonderful introduction. So thank you again.
Thank you for the invitation. Thank you all.
So good morning, everyone. Thank you also from me. I'm really happy to be here. Thank you very much to the Saggiatore Musicale and the Fondazione Golinelli. I'm also quite proud to be here because I'm involved. I'm part of the remake on the remakers. So for me, it's really a pleasure to present this round table, talking and listening about two case studies. We already had a short introduction in the previous focus. So we will have two case studies, one about NEMUS, titled Tastiera aumentata e simulazione numerica, which we will have Michele DUCCHESCHI and Riccardo Russo, and I give you with pleasure space for presenting your project, your case study.
Okay, so welcome to, well, this second NEMUS talk. This is a slightly longer presentation about the NEMUS project, which will run across three main axes: a geographical axis, a temporal axis, and a thematic axis. But before uncovering the axis, I would like to listen to a sound example. Well, I don't know what's happening here. Well, that was a sound example that was generated through a digital voice accompanied by an acoustic voice. So the digital voice was entirely created by a digital agent that was run through my computer through a fully synthesized algorithm. And then the acoustic voice was overlaid by me playing acoustic guitar in my music studio in Brescia. And the interesting thing about the sound synthesis part is that my computer was playing a guitar that I simulated within it, although I've never seen the guitar. The guitar is currently living in a museum in Spain, and I've never had access to it. But I was able to extract a lot of useful information for it because a person that I have never met created a huge database with a lot of very useful data about 65 Spanish guitars that are currently living in museum collections and private collections in Spain. And most of these instruments aren't playable. So my computer was playing a guitar that is currently, in fact, unplayable because it's broken. It belongs to a museum. But Dr. Morris, this person I've never met, he somehow followed the principles that today we call the principles of open science. So the FAIR principles, findability, interoperability, reuse of digital assets. And the database is so good, and it was published on Zenodo, that it was downloaded thousands and thousands of times. And Zenodo is a great way to share data following open access practices, because you have a version control, you have a digital object identifier which associates your archive with one precise object, and you can share a lot of heterogeneous data with it. So it's fantastic. And thanks to Dr. Mores's work, I was able to play an instrument that is currently unplayable and that I have never access to. And probably Dr. Morris didn't even know that by publishing that database, somebody would come and synthesize a full guitar. Actually, all 65 of them are simulated in my computer. So he probably had no idea that somebody could do that with the data that he shared. But that's precisely the principle of open science. And that's exactly the principles that we're following within the NEMUS project. So in order to understand a little bit more about this project, I would also like to introduce the first axis of this project, which is the geographical axis, because NEMUS is rooted in two main places. One is Edinburgh, where NEMUS was conceived, and the other one, of course, is Bologna, where the project currently lives. So these two cities are important because they host musical instrument collections and very specific instruments. The first one is the Johannes Ruckers from 1638 that was supposed to be a case study for the project. And it's an unplayable instrument, which belongs obviously to the Ruckers tradition, and which has the, well, if you see that the keyboards are misaligned, so that's a construction details that is not found very often in instruments around the same era. And because the instrument is so particular, obviously the Russell collection, where it belongs, decided not to restore it and to keep it in its original condition. But then we moved the project to Bologna, so we couldn't have access to that instrument anymore. And therefore, we changed our case study to the 1547 Trasuntino, which is currently hosted in the Tagliavini collection here in Bologna, and whose beautiful copy by Roberto Livi you will be able to see tomorrow. It will be revealed to the public tomorrow, so you will be able to play and see this beautiful piece of art that is a copy of the Trasuntino. But since NEMUS dealt with the Ruckers tradition, there is a third city that is really important, although I've never been there, but it's the home of the Ruckers. It's Antwerp, which has a guild, or it had a guild, the Guild of St. Luke, which was the guild where instrument builders had to sign up. So NEMUS moved from Flemish to early Italian, but there is one common thread across these three cities, Bologna, Edinburgh, and Antwerp. And this thread is Grant O'Brien, who I'm sure a lot of you know. And I had the pleasure to meet and become friends with at the time when I lived in Edinburgh. And at the time when NEMUS didn't exist, I was drafting my project. I didn't know, I had a very vague idea of what I wanted to do at the time. And Grant was really instrumental in shaping that idea. And we would meet in pubs, drinking beers a lot of the time, discussing harpsichords. And it was all great. And I was very ignorant. I'm still very ignorant about organology today, but I was a lot more ignorant at the time. And Grant would get furious with me, and he would say that I didn't understand anything because I was ignorant. And he was right. But at least on one thing we agreed. And the thing is that we were oriented into safeguarding originals and building copies. And I would be doing that using digital technology. And I would have to develop a methodology to do that because my methodology didn't exist. But Grant and I both shared the idea that the method in building is essential. And Grant obviously at the time was already known for having developed his own method, which is, we would say, scientific, because it uses regression analysis. It uses understanding measures, measures across places, across eras. So there is a method in organology that he became famous for. And my method in organology had yet to come because the project didn't exist at the time. But this method allowed Grant to make conclusions about instruments. For example, he was very passionate about the 1679 Joseph Johannes Kusche, which is a non-playable harpsichord that is currently hosted in Calgary. And this instrument doesn't play, so we don't know whether it sounds good or not. But for Grant, this was a masterpiece of the Rukers tradition. And how did he get to that conclusion? Because he unveiled certain properties about it through regression analysis that are hidden to the naked eye. So by measuring the distance between the jack slots and making proportions and figuring out what units were in place in Antwerp in 1679, he would grab me from the neck in the pub while I was trying to drink my beer saying, "Michele, you don't understand. This instrument is a masterpiece." And you can agree with that or not, but the thing is that there is a method. He can say that because he studied the instrument. There is some evidence that what he says is rooted into something that is methodological. And why do we need a method? Because obviously the Rukers at the time of the Guild of St. Luke also had a method, but they didn't have open science. So they respected corporative ideas because obviously they had a business to protect, and therefore all the knowledge they had remained within the guild and is now gone. And now we have to have people like Grant O'Brien, an organologist, to study the problem and to tell us exactly how to build copies. And that's precisely what we're trying to do within the NEMUS project, except that our technology is entirely digital, but the principle is the same. We want to create something that is very new because digital building tradition is 40 years old, which is nothing compared to traditional building traditions. So it's hard, but we're trying to do it following these very open principles or fair principles that come from open science. So the three pillars of NEMUS are numerical simulation, which Ricardo is going to talk about, experimental analysis, which we will see in this afternoon's talk by Sebastian, and then the haptic interfaces, which we briefly saw earlier and which I will also tell you about shortly. But I will let Ricardo present his part on numerical simulation first.
Hi, everyone. I'm Riccardo, and thanks, Michele, for the introduction. And I will, as Michele anticipated, I will speak about numerical simulation, which is the foundation of physical modeling, which is a fundamental field of research in NEMUS, as it provides the sound source for the digital instruments. So when in NEMUS, when we there are particular characteristics that we need from these numerical simulations. So we want them to be accurate, stable, and efficient. And these are three keywords that I will now explain. So first of all, since we're aiming at heritage preservation, the simulations must be as close as possible to the real vibration of instruments. This means that the mathematical models must be very complex and usually must include nonlinear components. Also, because the final goal is building a synthesizer, the simulations must work well in all possible situations. This feature is called stability, and although it might seem a bit obvious, stability is a crucial concept in the field of numerical simulation. It makes sure that the simulation doesn't blow up or stops working in the middle of a sound, for example. Finally, real-time audio software runs at 44 kilohertz, 44.1. So we want our simulations to work well and to be efficient enough to run at this rate on consumer laptops. So no supercomputers, but just computers like this one, for example. And these three characteristics clash with each other. So accurate and stable simulations are typically computationally expensive. So commercial simulation software, usually based on finite elements, such as console, for example, is not suited for this task. So in NEMUS, our research in numerical simulation focus both on developing accurate and complex mathematical models, but also on designing state-of-the-art numerical integrators. Now, this is the standard workflow that we follow. So first, the simulation algorithm is prototyped in a scripting language, such as MATLAB or Python. Then a port is made into a more efficient language, such as C++. And then finally, real-time software is built around the simulation algorithm by developing the user interface, user experience, controls. So in the end, what we do is really building a synthesizer out of the simulation algorithms. So I spoke about physical modeling, but what is physical modeling? A very general definition is that this is a family of sound synthesis techniques based on the digital simulation of physical systems. So in practice, the idea is to develop a mathematical model of the instrument and then solve the resulting equations with numerical methods. This is a very broad definition because actually physical modeling has several applications which can be grouped into main categories. The first and more historical concerns the study of the acoustical properties of systems. With the advent of the first computers, researchers began implementing simulations of vibration of systems in order to study their physical properties. The second application, which is more modern, here we are at the end of the 80s, beginning of the 90s, is sound synthesis, specifically for computer music. Here, researchers started to take techniques developed in the field of the research of acoustical properties and apply those to produce sound specifically for computer music. One example of this is the synth Yamaha VL1, which was released in '93, and it's based entirely on physical models. Now, I mentioned computer music, but of course, computer music didn't originate with physical modeling, but it has a long history itself. This starting too with the advent of the first computers. And over time, various techniques for sound synthesis have been developed, and these can be grouped in three categories following the taxonomy proposed by Julius Smith. We have recording-based techniques such as sampling, granular synthesis, and so on. Spectral techniques such as additive synthesis, or so-called abstract techniques such as FM. And all these methods have very different principles which they're founded on, but they all have one thing in common, which is they're focused on sound perception. So they're focused on modeling what the ear needs to perceive. On the other hand, we may say that physical modeling models sound at its source, directly replicating the behavior of the instrument that produces it. So the underlying idea is that if the model is developed with a sufficient level of detail, it will behave very similar to its real-world counterpart, and the resulting sound would be very close to the actual instrument. So on one hand, we have the ability to obtain very realistic and natural sounds, and also the full control on the models. This is because, unlike, for example, in sampling, where we record an instrument and the result is very accurate, very close to the sound of the real instrument, but that is the instrument and we cannot change it. In physical modeling, the physical parameters of an instrument are merely numbers that we can change in the simulation. So for example, we can change the tension of a string, the material properties of a string, and so on. And this offers great flexibility. But all of this naturally comes at a cost, which is the computational load of the simulation algorithms, and also the complexity of the models themselves. And as I anticipated before, developing and solving accurate mathematical models is very demanding. So typically, it is necessary to approximate the mathematical models to reduce the computational load. But this, of course, comes at the cost of introducing discrepancies with the real instrument sound. So the goal for us is to strike a balance between these two fields. Here we have a series of physical modeling techniques. We use both classic simulation methods such as finite difference or finite elements methods. There are techniques that were developed specifically for physical modeling, such as digital waveguides or mass and spring nets. Our technique we use extensively is model synthesis, which is based on the Fourier representation of sound. So we decompose vibration into a set of sinusoidal oscillations, and this has the advantage of allowing to set the decay time for each frequency, and this is particularly convenient because it allows very realistic result. So up until now, I've been speaking very generally, but I wanted to show you what we actually do when we want to model an instrument. So first, we start by defining a mathematical model that describes the object that we want to simulate. So in this case, for example, we have an example of an isolated string. Next, we need to discretize the spatial axis. This is necessary because computers cannot handle continuous quantities, but we must sample them. So what we end up is a series of points distributed in space that moves with time. Then we need to sample time as well, because it's another continuous quantity which we cannot handle with computers. And at this point, we can advance the simulation with numerical algorithms. Now, what I showed you is represents the workflow in the finite difference method, but actually it's very similar in all the techniques I showed you before. So finally, the result is very similar to something like this. So here we have the simulation of a string model, which is connected to a bar that acts as a bridge. The movement, of course, is exaggerated for more clarity, but this is exactly the model that we use for modeling, for simulating guitars, for example, the guitar we heard at the beginning of the presentation. And usually we take the movement of the bridge, we pass it through a filter that simulates the behavior of the room. And this is the result. Hopefully it will work. Sounds, yeah, exactly. So and Michele.
It's unfortunate because the sounds are really good, but I will share them with you later. And I will be very, very brief regarding the last part of the presentation, which is the interaction with cultural heritage. So how do we go about playing these instruments? And this is a hardware part, and this is a collaboration we have with museums, and particularly with San Colombano, which is host to a lot of playable instruments, except for the Trasontino, which is the only unplayable one within the collection. So the idea of augmenting a collection of musical instruments with digital technology is not new. And one project is the Tromba Marina. Stefania was involved in it, so you can ask her about it. But I would like to focus a little bit more on the McAlpine project from 2014, which is a project that he developed within the Benton Fletcher collection, which very similarly to San Colombano is a collection of playable musical instruments, and Benton Fletcher wanted the collection to remain playable for students and pupils. But obviously that clashed over time with the problem of preserving the same instruments, and that's why the museum decided to sample most of them and to create this double manual plastic keyboard to play the sampled instrument through a computer. So as you can see that the setup is a little bit clumsy because you have a screen and you have these two plastic keyboards and these, loudspeakers popping out. But the public kind of liked the whole project, except that they found that the haptic response wasn't very good. So the realism of the whole experience was prevented by the fact that you were interacting with a plastic keyboard and not an actual keyboard. And that's why for us, it was really central to change the design and to come up with something that looks a lot more like an actual harpsichord. And that was built by Roberto Livi. So as you can see, it's got the full mechanics of a harpsichord, except that the soundboard is really short. So how do you turn that into a digital instrument? Into a digital instrument, you install, well, what we did was to install a sensor optical system within it. So we attach these gradient stickers to the sides of the jacks and optical sensing QRE113 that are able to detect the amount of light reflected by the stickers. So we did a lot of prototyping, and this process went through multiple iterations. So there is a small 3-key prototype on which we do most of the prototyping work. And then the Mark 1, which is currently in San Colombano. And then the Mark 2, which is an evolution of the same system. And as you can see, the main difference is that the circuit boards aren't soldered, but we have pins connecting them. So replacing the boards is really easy, and it makes maintenance a lot easier. So the deployment is the keyboard is now fully deployed and playable. And I have maybe no sound for this one, but an excerpt from our upcoming documentary of the keyboard being played in the museum. And it's unfortunate because the sound of this video really shows you what you don't hear when you play the keyboard, because external people can only hear the mechanics of the keys. But then when you wear the headphones, you can, listen to this instrument. And I think it is very, very beautiful, and it's a very amazing way to augment a musical instrument collection and to make the experience a lot more accessible and open. So thanks for your attention.
Thank you very much. Thank you both, Michele and Riccardo, for this very inspiring presentation, and also for giving an opportunity for taking care of these instruments that cannot play. It can, and using the technologies and science. And I think we will have a moment for having a discussion after, maybe during the break lunch. And now I propose to go on with the second case study. It's involving the remakers, and it will focuses on how we can build a protocol of documentation for the historical keyboards. And I would introduce Eleanor Smith that will introduce the other participants, scholars, and PhD students. Thank you very much.
Thank you, Ilya, and Good day to everyone. I'm Eleanor Smith. I'm an organologist and a researcher with the Remake project. With me today, I have my colleagues Joel Spearstra, who is the principal investigator at the University of Gothenburg, Jacopo Uberti, who is a doctoral student in conservation at La Sapienza, Università di Roma, and just coming up to the stage, we have Andrea Gulli, who is a researcher at the University of Pavia in computer science and is building our and developing our platforms for sharing all this information. And today we're going to be talking about a new protocol that we are building for documentation of historical keyboard instruments. So I would like to begin with two short paragraphs directly from the Remake description of action. To fully appreciate the complexity of sounds as they emerge from the interplay between performers and their environments, we need to reconsider the traditional way in which organologists examine historical instruments. The study of materials and their behaviors, as well as even the most updated organological approach to the object, are not enough to understand the complexity of historic keyboard instruments and their affordances in music making. Instead of rejecting the interdeterminacy related to the human components, we aim to actively explore the subjectivity of the people involved in the process. So how do we go about building a new protocol for examining musical instruments? We first need to acknowledge that there are many different documentation approaches depending on the needs of different disciplines. What is essential to the organologist may seem trivial to a performer, and not even the conservator and organologist would necessarily agree on how to document an instrument. We feel it is important to discuss these elements that each discipline finds important, and by bringing these together, Remake aims to build up a modular protocol that can then be adapted to the individual needs of a particular study. However, by also establishing a core set of research questions, we hope to develop a template that can also then extend to other instruments. In this presentation, we will look at two research questions or challenges that we are currently working on and how we are looking to address them. Sorry, I just got a notification that the Mac is about to die. Thank you. I feel it's also important to acknowledge that in building this protocol, we are standing on the shoulders of our peers and esteemed colleagues. For example, the project in 2013 to 2016 to document all 18 Ruckers and fake Ruckers instruments in the Musical Instrument Museum in Brussels. This resulted in the fantastic volume edited by Pascal van der Vellen, The Golden Age of Flemish Harpsichord Making. This book skillfully combines approaches from conservation, organology, social history, and more to explore what might even be called the microecology of the Ruckers workshop. Building on projects like this and building a central research hub where the protocol will be available in an open access format is one of our most important aims. I'm now going to pass over to first Joel and then Jacopo to discuss one of the founding research questions of the Remake project.
Thank you. The question of why key carving looks the way it does on historical clavichords has been exercising our brains for a while. I think it's very important to say that the work we're doing on this question is entirely because Keith Hill, the instrument builder in the States, has looked at the qualities of materials and their resonance for a long time and has argued that they are manipulated in order to improve their resonance. So the way that the keys look may be as a part of a search for a more resonant key. And I can only say that I have empirically been experimenting with this for many years. And just briefly to talk about the method, every time I go to a historical clavichord, I do the same thing, not because it's right, but because it's what I've always done. And that means that I'm building a sort of a database in my head of the way an object sounds to me based on the same experiment, which is to hold the key at the balance point. And the only argument I have for that is because that's where it's damped anyway, and to tap where the finger touches the key, and then to tap where the tangent for the clavichord sticks out. And in almost every case, the historical clavichords have the same tone in both places, and the keys ring like bells. And to look at various builders and copy their distinct recipes for how to produce this would take a long time. But it is possible for me to satisfy myself that it's that one can extend both the quality and sound of the instrument doing this, that one could actually have the instrument extend its resonance by almost a second, which is a lot for a clavichord. And one last little thing from this morning, I asked AI, I realized as I was thinking about this process on the way to this conference, when I tap, you don't know this yet, Ellie, when I tap the key, I have always closed my left eye. I don't know why. And I can't stop doing it. It's just, I think sometimes I am conscious of it and think, is this a tic? Am I just beginning to get up to be a nervous old person? AI told me this morning that when you close your left eye, you are damping information overload and allowing yourself to concentrate rationally on visual or oral information. So there is I think when we let cognitive science into these kinds of experiments, we will learn a lot about the behaviors that our bodies already know how to do.
Would you like to say a couple of words about how we have tried to document this process so far?
The process of documenting is, we are actually confronting complexity by trying to document this. We can take measurements of many places on the key to try to document a recipe for carving the key. We also can take pictures with grazing light. We have done initial experiments with tapping the keys and recording the resonance of the keys at using an experimental rig in Cremona.
And this is where Jacopo's expertise comes in. Stay close.
Okay. Hello, everyone. I would like to start by introducing the topic of documentation and the important role it plays in conservation. Generally, the critical moment for documentation coincides with a possible restoration intervention. This is because an intervention represents, in fact, a point of no return regarding the artifact's original condition. This is also the moment when one is called, or should be called, to detailed study of the instrument. Documentation, therefore, should not be seen as a simple technical report, possibly supporting the restoration project, but as a guide for preventive conservation as well as a tool for storytelling and valorization. In the pre-intervention phase, documentation must be as rigorous as possible. We analyze the morphology of the artifact, any previous intervention, and its state of conservation, integrating historical cultural study with possible multidisciplinary approaches. However, not all institutions and even less so private owners have access to advanced equipment. In addition, moving the artifact can be an additional limitation. Generally, the critical moment for documentation coincides with a possible restoration intervention. This is because an intervention represents, in fact, a point of photogrammetry is a very interesting tool, even with some limitation. It has a limited accuracy compared to 3D scanners and requires scale references during acquisition. Its advances are not invasiveness, high portability, and low cost. The result gives a highly detailed texture with a good color fidelity, depending on image quality and the profiling, of course. Disadvantages include a strong dependence on lighting, reflection, and transparencies can cause errors, time-consuming acquisition and processing, and inability to capture hidden geometry. This is deliberately extreme setup, very low cost and portable, even Ryanair proof. The level of the Visby Scotland Museum clavier organ was prepared using the two camping LED lamps and metric and alignment references, especially needed in a less controlled setup. The goal was to reduce unwanted effect for reflection and uneven lighting. During processing, we obtained the 3D model and the integrated texture. However, the texture can be misleading, making the model look more accurate than it really is. Here, acquisition was done with a smartphone. Low light and no tripod caused the camera to open the aperture, reducing depth of field and affecting some areas. Despite this, the model still shows details that would be hard to capture with calipers or rulers. For second use, especially for parametric reconstruction, the meso has very high density. For example, this lever, 30 centimeters long, has over 5.5 million triangular faces. To reduce the computational cost, mesh decimation is needed, accepting some loss of detail. From the simplified model, we can extract cross-section for parametric model. Alternatively, starting from the point cloud, we can follow a scan-to-bin workflow to create a NURBS model. Even then, data density usually needs to redust.
So this is challenge number 2, keyboard touch or keyboard control. If we consider the player keyboard jack, string pluck as an integrated system, how does this affect the sense of control a player has over a keyboard? So what measurements do we need to take? And this is another major challenge when documenting keyboard instruments. It's how to record keyboard touch, something that is a major consideration for the performer. Common methodologies include measuring the touch depth, how far a key can travel, or measuring the touch weight, how much weight does it take to move the key lever and pluck a string. This can, of course, be problematic, though, on instruments with no strings or missing jacks. It would also be useful to be able to model different changes to this integrated system of performer key lever pluck, such as a common change that's made a historical instrument, which is the moving of the balance rails. And this has been done in some research projects using action models and with slow motion videography. Laurie Libin highlighted both the challenge of documenting touch and its importance in his 2019 article in Keyboard Perspectives, where he also outlined many important measurements that contribute to the system of player-instrument interaction. We are investigating some of these questions through solving some problems with touch on a modern instrument. Magnus, the performer and owner, came to us with a problem he wanted us to solve. His instrument is not behaving in terms of touch how he would like it to. Joel was able to understand these problems as a performer himself and, as an instrument builder, had a proposed solution taking as inspiration the cell harpsichord that is at the center of one of Remake's microecologies. Joel and I looked at the modern instrument together, and we noticed one problem in particular, which you can see in the slow motion video, that the jacks are bouncing a lot, which suggests there is excess energy somewhere in this system. In the process of reverse engineering a solution to this problem, we have been considering how the harpsichord key lever acts as a lever with energy transfer from finger to pluck. This means we are developing a set of measurements that we need to be able to take to model this behavior. Many of these do appear in the Lebin checklist, but some others do not, and do appear to be important. Whilst our test case is a modern instrument in regular use, these measurements can then be applied to instruments that do not play. And even where elements are missing, it would be possible to add in data sets from other historical instruments to create an estimation. Working as we are to solve a definable issue also gives us the chance to test the protocol as we make changes to the instrument in a way that simply isn't possible on cultural heritage objects. To give Libin the final word, we then need to combine this quantifiable data with the qualitative descriptions of keyboard action, bringing the organology and the experience together. I'll now hand over to Andrea to give an idea of how the Remake Hub will start to make sense of all this data as the protocol will eventually produce.
Thank you, Eleanor. Thank you, everyone. As is clear, the challenge is to build knowledge, shared knowledge from data. Data is, of course, very heterogeneous because of data types, because of multiple perspectives, as we said before, a lot of interdisciplinarity, and of course, because of possible multiple interpretations. We want, of course, the FAIR principles to be applied of open science, so accessible, interpretable, and more on top of that, we would like to have it to make sense across all the disciplines. And of course, there are big constraints like preservations. So as Michele explained before, Zenodo is great for documenting, versioning, and keeping an identification on all the produced data we have. It possibly to allow growth and cross-domain links, and support interaction, not just storage. So for yeah, this is let's say the first prototype of the framework that we had in mind. I would like to being here not to explain all the details, but to just bridge, as Eva told before. It's very important to bridge between the knowledges. I took some notes from the previous presentations, and I think that these citations make a lot of sense in this project. We heard before that technology is not neutral, so it makes a lot of sense to have a layer to interpret the knowledge that have been shaped, to have the user to have an interface that he can understand. We focus, as Massimiliano said before, on the network, not on the object. So it is important the relation character of the knowledge, not the object, the absolute object, let's say. Of course, the method is really important, because this lets us to pass on and to be interoperable and to be open to anybody. And yeah, basically is this.
Thank you, Andrea. So we're going to wrap up when we recently visited the Greifenberg Institute, Helmut Bolk said something that really resonated with me. He told me that each time he approaches a new instrument, he does it as a complete blank slate, rather than imposing his, and I add, rather vast experience over what he sees. He takes the attitude that he instead learns from the original builder, as if an apprentice in the workshop. One of the aims of Remake, as we have said, is of course to bring the human element into our protocol as well. From the experiences of makers and curators, the embodied knowledge of builders and performers, and the didactic experiences of teachers and their students. And as we are at the beginning of the Remake project, we certainly don't have all the answers. But we're building up a lot of questions, drawing on each other in the first instance for our different strengths, and exploring approaches and indeed technologies from different spheres. We're already learning. And as we build our resources, both digital and physical, these will of course be available open access on the Remake protocol. So thank you for your attention.